Good morning, student of class 11. Hope you are well at home and you are doing your work properly. Today I am going to start a new chapter, and the first topic of this one chapter is force. What is force? Simply we can say that force is a pull or push, and which can change the direction of a object and the state of rest and the state of uniform motion. So, force may be defined as an external agency, a push or pull, which change or tends to change the state of rest or of uniform motion or the direction of motion of a body. And the unit of force is Newton and CGS unit is dyne. And the dimension of force is mLT to the power minus 2. A force applied on an object can produce four types of effects, such as first one, force can start or stop a motion. Means if we applied force on a stationary object, and it can bring the object in motion, and if we applied a force on a moving object, it can stop the motion of the object. यदि हमने फोर्स को किसी स्टेशनरी ऑब्जेक्ट पर अप्लाइड करा तो वो उस स्टेशनरी ऑब्जेक्ट को मोशन की स्टेट में ला सकता है, और यदि किसी मूविंग ऑब्जेक्ट पर अप्लाइड करा तो वो उसके मोशन को स्टॉप कर सकता है. फोर्स कैन चेंज स्पीड ऑफ एन ऑब्जेक्ट मेकिंग इट टू मूव स्लोअर और फास्टर. किसी मूविंग ऑब्जेक्ट पर फोर्स अप्लाइड करने से फोर्स उस मूविंग ऑब्जेक्ट की स्पीड को स्लो कर सकता है, और यदि उसकी मोशन की डायरेक्शन में फोर्स अप्लाइड हुआ तो उसकी स्पीड को इंक्रीज कर सकता है. फोर्स कैन चेंज द डायरेक्शन ऑफ मोशन ऑफ एन ऑब्जेक्ट. इफ ए ऑब्जेक्ट इज मूविंग वी अप्लाइड अ फोर्स एंड देन इट कैन चेंज द डायरेक्शन ऑफ मोशन और डायरेक्शन ऑफ ऑब्जेक्ट. फोर्स कैन चेंज द शेप ऑफ एन ऑब्जेक्ट. फोर्स जो है किसी ऑब्जेक्ट के शेप को चेंज कर सकता है. लाइक ए स्प्रिंग, and we applied a force on the both end of the spring, then the shape of the spring will change. A ball of clay. Inertia. Next topic is inertia. Newton's first law of motion is also called Galileo's law of inertia, and according to this law of inertia, the tendency of a body to oppose any change in its state of rest or uniform motion is called inertia of the body. According to this law, यदि कोई बॉडी रेस्ट में है तो रेस्ट में ही रहना चाहेगी, और यदि यूनिफॉर्म मोशन से मोशन कर रही है, यूनिफॉर्म स्पीड से मोशन कर रही है, तो मोशन में ही रहना चाहेगी. And types of inertia, there are three types of inertia. Inertia of rest, the resistance offered by a body to change its state of rest is called inertia of rest. If you want to change the state of rest of a body by applying a force, then this body will remain to the state of rest. It will oppose the change in its position. Inertia of motion, the resistance offered by a body to change its state of uniform motion is called inertia of motion. सपोज कोई बॉडी यूनिफॉर्म स्पीड यूनिफॉर्म वेलोसिटी से मोशन कर रही है और हम उसकी स्पीड को चेंज करना चाहते हैं, तो वो बॉडी जो है उसके स्पीड में चेंज करने का अपोज करेगी. सो दिस रेजिस्टेंस offered by a body to change its state of uniform motion is called inertia of motion. Next, inertia of direction, the resistance offered by a body to change its direction of motion is called inertia of directions. Next is Newton's law of motion. Sir Isaac Newton 1642 to 1727 made a systematic study of motion and extended the views of Galileo. He arrived at three laws of motion which are called Newton's law of motion. Newton's first law of motion. This law states that every body continues in its state of rest or uniform motion in a straight line unless it is compelled by some external force to change that state. This law states that यदि कोई बॉडी जो है यूनिफॉर्म मोशन में है तो वह मोशन में ही रहेगी, और यदि रेस्ट की पोजीशन में है तो वो रेस्ट की ही पोजीशन में होगी जब तक कि उस पर कोई फोर्स क्या ना हो, अप्लाइड ना हो. नेक्स्ट, मोमेंटम. Momentum of a body is the quantity of motion possessed by the body, and it is defined to be the product of its masses and velocity v. And P equals, momentum is denoted by P and P equals m into v, and the unit of momentum is kg meter per second, and its dimension is mlt to the power minus 1. Variation of momentum. How the momentum variate. Let two objects each of mass m are moving with different velocities v1 and v2, with v1 greater to v2, and here momentum of object first p1 equals mv1 and p2 equals mv2. Then we will divide p1 by p2. It will be p1 by p2 equals mv1 upon mv2 equals v1 upon v2. P1 upon P2 equals V1 upon V2, then V1 greater than V2, then P1 greater than P2. And the momentum of bodies having equal masses are proportional to their velocities. Case second. Let having heavier object of mass m1 and lighter object of mass m2. Suppose both the objects are moving with the same velocity v. Then P equals m1v and P2 equals m2v. P1 upon P2 equals m1v upon m2v equals m1 upon m2 equals P1 upon P2 equals m1 upon m2. Here P1 upon P2 equals m1 upon m2. As m1 greater than m2, then P1 greater than P2. The momentum of bodies having equal velocities are proportional to their masses. If the object of the mass is greater, then the momentum of the object will be greater. Case third. Let two objects having equal linear momentum, thus P1 equals P2, then M1 V1 equals M2 V2. From here V2 upon V1 equals M1 upon M2. As M1 greater than M2, then V2 greater than V1. Thus the velocities of bodies having equal linear momentum are inversely proportional to their masses.